All right, for number 13, you're asked about matching the appropriate range with the function. So here, it helps to kind of identify exponential, quadratics, and linear functions first, and then we'll talk about plugging it into a calculator and identifying from there what the ranges will be. So looking at f of x, I have a power of 2. So anytime you have a power of 2, it is an indication that this is a quadratic function. And so a quadratic function is going to have a range that is y is greater than or equal to whatever the vertex is. So you're looking for y is greater than or equal to, or y is less than equal to. So it could be or y is less than or equal to. So either one of those will be your matching range for a quadratic function. So this quadratic function is a positive one. There's no negative out front, so it's going to be a happy face. And anytime you have a happy face, the range is going to be greater than y is greater than or equal to. So for this one, without even graphing, I know that is y is greater than or equal to something. If you look at your answer choices, there's only one answer choice that is y is greater than or equal to something, and that is C. But looking at a graph, so how you would plug this in, and I'm going to tell you why I'm doing it this way, because I want to avoid having to plug this one in, because it can be annoying to plug in. So the other three are pretty easy, so I'm going to work on g of x last. But if I can figure out all of this based on just how it looks, then looking at it in a calculator, I can kind of be 100%. I can absolutely be 100% in what I'm given. So if I plug it into my calculator, so it's x plus 4 squared minus 2. So I just type it in exactly as it appears. And then you can look at the graph and you could definitely see it's a quadratic, but maybe these dashes are too small on your calculator. So I would look at the table and I want to know how far down, because it's going to be a minimum point. So that minimum point means I'm looking for the lowest y will ever go. So if you look at y here, I'm at -5 now. And it looks like it's at -2 is the lowest it goes, and then only up from there. So if you go up, again, -2 is the lowest it will go. So in other words, y is going to be greater than or equal to -2, which is C. So f of x matches the range of C. So again, I'm going to skip g of x because it's an exponential function and could be a little confusing to plug into a calculator. So if I'm given something like this, I definitely want to plug that in last or deal with it last. 3x plus 50, well, you should know, or you should see that this is basically y equals mx plus b form, which is a linear function. And a linear function is always going to have a range of all real numbers. So if you don't believe me, you can plug it in. Y equals 3x plus 50, and then hit the graph. If you don't see your graph for whatever reason, you can hit zoom and then 0. Zoom 0 will zoom out or try to fit it the best it can on your calculator. And as you can see, this graph will continue to go forever and ever, increasing forever and ever that way. So there are no limits for y. And if there are no limits on y, the range is all real numbers. So that is A. Moving on to j of x, -2 times x minus 5 raised to the second power. So again, raised to the second power indicates that this is a quadratic formula. So I've taken care of A, that's gone. Taken care of C, that's gone. So remember that a quadratic formula is going to be y is greater than or equal to, or y is less than or equal to. So you can kind of keep it differentiated from an exponential function in that you have the or equal to. So it's greater than or equal to, less than or equal to the range. So looking at my choices here, process of elimination, I'm going to say that D is the range of j of x. I say that because it is the only one left that is y is less than or equal to. This time it's less than, not greater than. But if I plug it into my calculator, let's see if I can make some sense of it. So negative 2 y equals negative 2 times the quantity x minus 5 raised to the second power. So this is how it would look when you plug it in. And when you plug it in and you graph it, I'm gonna have to zoom back out, I think. Zoom 6 to zoom back to standard, and there you see it. Looks like it is a maximum point now, so I'm worried about what is the maximum point. Looks like it hits the x-axis, but maybe I'm not sure, so I'm gonna go to table. Now I'm gonna see the biggest that y gets. If it's a maximum point, I'm looking for how big y can possibly get. And it goes from negative to 0 and then back down to negatives. So the biggest it'll ever get is 0. So if 0 is the biggest it'll ever get, that means y is going to be less than or equal to 0. So this is going to be D. Which good news is I can avoid trying to plug this into my calculator because all three of these have been eliminated. B is g of x. You also can, it's a dead giveaway because if it's just greater than or less than, not greater than or equal to or less than or equal to, then it's going to be an exponential function. Because remember, an exponential function will have an asymptote, and that asymptote can't be crossed. So it's got to be either above that asymptote or below the asymptote. So it can't be equal to. So if you don't see an equals to or equal to range or inequality, then you know it can't be an exponential. But for this, process of elimination did us well.